Watch this fold. The plastic screen dents at the crease and stays dented. But 30-micron glass, thinner than a hair, bends the same way and springs back flat. The crease isn't the hinge. A foldable sells one promise: unfold it and a big, seamless screen appears. A visible line down the middle breaks that spell instantly. Surveys of hesitant buyers put the crease at the top of their worries. So here's the real question. Is that crease a flaw makers can erase, or a physics tax foldables can never escape? The answer decides whether these phones go mainstream or stay a pricey novelty. Start with why a screen has to bend at all. Fold anything flat and the two sides fight. The outer surface has to stretch to reach around the bend. The inner surface has to squeeze. That stretch and squeeze is called strain. The tighter the fold, the more of it you get. Here's the part people miss. The distance from the fold line to the surface is what sets the strain. Bend around a big soft loop and the surface barely stretches. Bend around a sharp knife edge and the same surface stretches hard. Engineers describe this as the bend radius, how gently or sharply the screen curls. A gentle curl might be 6 or 8 millimeters across. A tight fold pushes down to 1 to 3 millimeters. Cut that radius in half and you roughly double the strain the outer layer has to survive. Every single fold. Now picture the very top layer, the one you touch. It sits farthest from the fold line, so it takes the worst of that stretch. This is why the exact material sitting at the crease matters more than anything else in the phone. Same fold, same radius, two materials. One shrugs it off, one gives up. So the whole crease story comes down to a fight between two cover layers. Which one cracks first? Meet the first material. Most foldables so far use a clear plastic top layer. A see-through cousin of the tough film in flexible circuits. Engineers call it colorless polyimide or CPI. Here's the catch with this plastic. It's soft and it's slow to bounce back. Push on a rubber ball and it pops back at once. This plastic is more like memory foam. Press it and it takes its sweet time returning, if it returns fully at all. That slow, incomplete recovery is the whole problem. Now fold it a few thousand times. Each fold pushes the plastic into the same bent shape at the same line. On its own, once it might recover. But there's a second ingredient: heat. The display underneath runs warm all day, and warm plastic is softer and even slower to spring back. Warm it, bend it, hold it, repeats. And the plastic slowly forgets flat. It takes a permanent bent shape right along the fold. You end up with a soft valley you can feel with a fingernail and catch in the light at the wrong angle. And it doesn't stay still. Every week of folding presses that valley a little deeper, because the plastic never fully undoes the last bend before you add the next. That's the crease people complain about on today's foldables. Not a scratch, not a defect. A material quietly giving up at one line. So why not just use glass? Now the challenger: glass. Instinct says glass at a fold is madness. Glass shatters. But go thin enough and glass does something surprising. It bends. This is ultra-thin glass and it's roughly 30 microns thick. About a third of a human hair. At that thickness, a sheet of glass can curl to a few millimeters and not break. That's the number in the title, 30 microns. Here's why glass wins where plastic loses. Glass is almost perfectly springy. Bend it within its limit and it stores that energy and gives every bit back, snapping flat again. It has no memory foam in it. It doesn't take a set the way plastic does, so it resists that permanent valley fold after fold. Same warmth, same thousands of cycles. The glass keeps returning to flat. So glass should end the crease. But glass brings its own weakness. Thin glass is brittle to a sharp poke. A dropped key or a hard fingernail press can start a tiny crack, and once glass cracks, it runs. It's also brutally hard to make 30-micron glass flawless. One microscopic flaw becomes a fracture line. Makers solve both by laminating a thin plastic film on top as a shield. And that's the twist. That protective film is soft again. So a sliver of the old plastic softness sneaks right back into the stack, and a faint crease can still form on the film above the glass. Which is exactly the corner Apple is reportedly trying to design around. This is where Apple's reported foldable enters, and it's worth a caution up front. Everything here is pre-release reporting, not a phone anyone can buy yet. Reports describe Apple chasing a crease you basically can't see. And the trick isn't one miracle material. It's geometry. Remember the rule from earlier. A tighter bend means more strain, and strain is what wrecks the surface. So the smartest move is to stop bending sharply. Most current hinges let the two halves close almost flat against each other, which forces a tight, punishing fold right at one line. Apple's design reportedly uses what's called a teardrop hinge. Instead of pinching the screen to a hard crease, the panel curls down into a rounded loop shaped like a teardrop and tucks into the hinge. Here's what that buys you. That rounded loop is a much bigger bend radius than a sharp fold. Bigger radius, less stretch. And this is the key. The bend is spread across a wide curve instead of concentrated on one line. No single line takes the full beating, so no single line gives up. Reports add a second piece, stiff metal support plates engineered under the display so the fold region stays flat and doesn't dish inward when you press it. Layer by layer, the stack is tuned so the soft parts don't get pushed past their limit. Put it together. Gentle teardrop bend, springy glass, firm support underneath. And the strain that used to pile onto one line gets shared out until no point deforms enough to leave a mark. At least that's the claim on paper. So here's the whole picture. The crease was never really a hinge problem. It's a contest between two materials. Plastic that takes a set and holds a bend, and glass that springs back to flat. And the referee is the hinge, deciding how gently or how sharply the stack gets bent. That's the master answer. Hiding a fold isn't magic. It's 3 moves working together. First, use a springy material like ultra-thin glass that refuses to hold a bend. Second, bend it gently. A bigger radius or a teardrop loop that spreads the stretch across a wide curve, instead of dumping it on one line. Third, hold everything flat from below with stiff support, so the soft layers never get pushed past the point of no return. Miss any one of the 3 and the crease creeps back. Keep the plastic film soft but bend it sharply. Valley. Spread the strain but skip the support. The middle dishes in. A truly invisible fold needs all 3 at once. Thin elastic glass, a strain-spreading hinge, and a stack that stays flat. That's the real reason some foldables crease and some might not. So next time you catch that line down a foldable, you'll know exactly what you're looking at. Soft plastic taking a set because the hinge bent it too sharply at one line. Whether Apple's teardrop trick actually delivers an invisible fold in a phone you can hold. That we only find out when it ships, and reporting isn't hardware. That's the follow-up I'll be testing next.